Good morning, everyone. My name is Shaina Bramley. I'm a senior associate with Michael Baker. I live down in Jersey, so I talk with my hands, so I'll try to, not give it away too much. How many of you have, let's just say, looked at the lighting design guideline? I'm not going to ask if you read all 82 pages. If you did, I've got prizes for you. Okay. So this is a topic that's near and dear to my heart. I met Steve a couple years ago at a conference. I'm a lighting designer, an electrical engineer. I've been doing this for 28 years. I know a lot about light bulbs. It's about it. I don't know about bridges or, I'm starting to learn roadways, but I'm a lighting electrical engineer. And 9 years ago on Mother's Day, my oldest son was riding his bike in between the junior high school and the library to return some library books. He was an avid reader, and he was struck in the crosswalk. He suffered a major TBI, and I had partial paralysis for a while. But he's doing good now. Okay, so there's a positive end to the story. But I thought, how can I combine what happened to me with lighting? And this is it. It's amazing. So I really want to thank Steve for allowing me to work with him on this project. So let's get started. All right. Oh, come on. Wait, I had it all go.
It might not be on
What?
the side there. Lost of it.
Yeah.
And
Oh,
on. Yeah.
there we go. What happened? Now?
Is there a dongle?
Wait.
There we
Oh,
go.
now it's changing. Do you have a different dongle? Why is it not using mine? How many dongles are going on? Okay. Don't know why. All right, so I'll just have to kind of stand back here. I have to walk and talk. So as we all know, we've got all these pedestrian safety countermeasures, right? Lighting is one of those, very obvious. It's an easy one, but it has to be done right. So we can save, 42% of the pedestrian fatalities and serious injuries. These are like measured safety metrics, okay? And when it comes down to guidelines, this is what my library looks like at home. I work with DOTs all over the country, and there's quite a lot.
Go back in front.
Go back in front.
I'll do the slides for you.
Oh, wait, why is there two clickers? Oh, I was using the wrong clicker.
No.
Oh, someone else put a clicker up there. Okay. All right, so we're good. Technical problems over. So these are my guidelines. How many of you think, okay, I'm staying away from that. How many of you think that all of these say the exact same thing when it comes to lighting? None of them. So how do you design it? Good luck, right? So what's significant about this new guideline that we put together is that I had to go through all of the different things that I think about for a lighting design project. And then we took that information, we were brainstorming, and we said, okay, let's now put this into a guideline. The guideline was supposed to be like this big, and it just kind of kept growing, and we're not done yet. We're just getting started. Okay, so the standard questions that I ask myself on every single project is, can you kind of see it? Which references should I use? What is the lighting design process? Do I understand lighting terminology? That's a big one. Which roadway features do I need to identify? How do I warrant the lighting? How do I justify it? You guys only have a limited amount of funds. How do you say, okay, this location is going to get lighting versus something else? What is the design criteria? Good luck. No, we figured that out for you. What equipment should I select? Now, this is very interesting. There's a lot of different manufacturers and products out there, so it's not like a one-size-fits-all answer. Where do I locate the lighting? How do I calculate it? That's a big one. And what should I show on my plans? Okay, so that's my process. These are all the things that we were trying to identify in this guideline. So the whole point of the guideline is to be a one-stop shop for everything that you need to design lighting from start to finish. It's it's not just for lighting designers, it's not just for traffic engineers, it's for the cities, the villages, municipalities, the DOTs, it's for everybody. So we can, we took all the information and try to put it together in one place. So one reference, I say nearly everything, there's a couple things that we've been talking about adding to it. So this is a work in progress. We want you guys to use it. We want you to understand it, apply it, and we want you to ask questions. If something doesn't make sense, let us know. We'll fix the application or the example. We want it to grow. But it goes through the complete lighting design process. I've seen a lot of guidelines out there and they're like, if it's a street, if it's this, if it's a sidewalk, if it's whatever, it's this foot candle, and that's like a flow chart. This is a process, it's a design process. Step one, we actually have a chart, and then every chapter pertains to the step. So select your application, select the approach roadway, whether the roadway is lit or not, complete the lighting warrant, select the lighting intersection lighting classification, what type of lighting is then warranted, select the design criteria, do the horizontal layout, the vertical lighting layout, that's something we're going to talk about, select luminaires, select the pole, complete the calculations, and submit it to Steve, and he'll either, yeah, Ron, where's Ron? So we also talked about lighting terminology. The big thing is, I've been doing lighting for 28 years, and not everyone understands the terminology. They think they do. Even my colleagues often get things muddled. So I took all the standard lighting terminology, and then we applied it to roadways, to crosswalks. So it's really terminology in context. And then we took and defined roadway terminology, because a lot of the warrants, a lot of these guidelines that you will see out there are written in kilometers, not mile per hour. Or they're written, for example, they'll have, we customize the warrant for highway corridor priority, right? Different ways to classify roadways here in Maine that doesn't pertain to, California or Jersey. We have a new automatic and calculated pedestrian warrants. So I know this looks very overwhelming. The whole point of this spreadsheet is to help you prioritize. Any lighting is good, is warranted, right? Well, I shouldn't say that, because we'll talk about that. But lighting is done well. You really don't have to say, should I do lighting well or not? Yes, it's almost always warranted. But sometimes you need to prioritize. Town comes to you or village comes to you and says, where do I put lighting first? And this will help you prioritize. Reclassifying lighting. So when you use those warrants, it tells you how to apply the lighting, how to design it. And we've got additional criteria that we added. Additional criteria. There used to be one that, how many of you have seen a Cobra head utility light on a wooden pole lighting a crosswalk? Yeah, that's, we got rid of that. We basically said if you're going to light a crosswalk, you have to do it well. And that means providing even illumination across the entire crosswalk, not just putting a beacon of light at one corner and hoping and praying that you can't see the person on the other side of the street. So that's kind of what we did. And all of this is more in detail. You can read it tonight, helps you go to sleep at night if you get we also consolidated all the lighting design guides. So we did a study. We sat down and we went through, 5 or 6 intersections that had recent pedestrian fatalities. And we looked at all the criteria, and then we looked at all the design guidelines, and we said, what is a good light level? Remember, the whole point of this is to make roads safer. That's all we're trying to do. Lighting is an art. If you have 1.1 foot candles versus 1 foot candle, you can't tell the difference. All right, so we're just trying to get close. That's the goal of lighting design. And then we have clear pedestrian lighting calculations methods. We have a lot of examples in here. So this is really good if you don't know how to do it, don't understand it. The examples in here are fantastic. More and more examples. A plug for the afternoon session will actually do work on 2 intersection applications, and you'll actually locate the lights. You'll try to figure out the horizontal grid, the vertical grids, and lay out the lights. I've got some fun giveaways, but the whole point is being a little personal here, but I wanted a guideline that was also flexible. Because a lot of DOTs came to me and said, we've got this guideline, and if someone's at 1.5 foot candles versus 1.4, should we reject it? I'm like, no. You have to think about it holistically. So let's talk about lighting terminology, 101, all right, I'm doing good. These are just terms, I'm just gonna talk about like 5 today. These are ones that people often confuse when they're reading about lighting. How many of you just read a lighting design standard? Okay, handful of you. All right, good, all right. Got some hands, yay, lighting people. So you got the Luminance method and the Illuminance method. They sound so similar, but they're completely different, right? The Illuminance method, the one on the right, think about it this way. If you can't see one's safe stopping distance in front of you, you're going to be looking left and right. This is like a crosswalk. This is where there's parked cars. This is intersections, steep hills, curved roads. That's when you use the Illuminance method, because you want to actually see the ground. And then we have the Luminance method. This other method, this is for when we're doing a long highway. And you guys God, these things are scary. Can't walk and talk. I know. So the Luminance method is designed for when you are on a long straight road and you actually want to see what's going on one safe stopping distance in front of you. It's looking at the light ahead of you and how much is actually bouncing back towards you. So if you don't have that one safe stopping distance, you have to use the Illuminance method. So just kind of basic terms. The other thing is contrast. When it comes to pedestrian safety, this is the most important thing, is contrast. Day, we have a crosswalk, a zebra crossing, black and white. Why is it black and white? Contrast, right? Fantastic, looks great. Then what happens at night? The contrast goes away. Come on in, it's okay. Front row seat for you. No. So we lose that contrast. So all we're trying to do with lighting is this. So if you have a crosswalk, but you don't light it properly, guess what? That's what you get. Is that safe? No. So that's our goal. This is just kind of a little chart, kind of shows the distance that you can see a pedestrian with headlights. So a lot of people say to me, Shaina, really, why do we need a guideline when the headlights will shine on a person when we get close to it? Seems a little silly, right? We're thinking about it from before the headlights get there. I know, I'm gonna walk, I keep walking, it doesn't like if I stand too long. So we're looking at before the headlights get there. I want to be able to see that there's something 200, 300 feet in the distance about to cross the road or in the road. That's the goal. Once the car gets there, those headlights take over and you've got 10-foot candles shining on that person. So it doesn't really do much. And that's what this chart, so there's a lot of studies out there. I actually read all these studies that are coming out. And what this little chart shows, just kind of, this is feet, and this is the actual impact of headlamps by distance. So once you get over 150 feet, something that far away, it's not really that far if you're traveling 45, 50, 60 miles an hour. It's going to approach fast. But this is the area we're trying to light, okay? That's the whole purpose. And this is what Steve was talking about before, this positive contrast. So negative contrast, the light's behind you, the person's silhouetted. The positive contrast is the light is in front of you, shining onto you, okay? Seems very simple. Like, really? Why do we need an 82-page guideline if you just put a light in front of the crosswalk? It's not always that simple. So something else I wanted to show you, positive and negative contrast. So I like this image because we've got a very bright street, a very dark street. Which one do you think has the better contrast to see the pedestrian? Isn't that interesting? The darker street actually pops the pedestrian. Now, what happens if they change their what they're wearing? Which one's clearer now? So it really makes a difference, okay? Because I can't control what everyone wears. Everyone wears a black jacket. And then we talk about Kelvin temperature. I know this is a very sensitive subject. So Kelvin temperature is that color of light, if it's warm or if it's cool. And there's just studies that go on that state that like the 4,100 Kelvin, 4,000 Kelvin is just a good, from a sight distance, from a color rendering, there's a lot of benefits to it. So this is a very sensitive subject, okay? A lot of people do like that warmer color. In my dining room, I like the warmer color. If I go to a restaurant, I like the warmer color. The purpose of lighting is for safety. It's for visual clarity. So I just want you to think about that when you're picking the color temperature. Are you trying to put the driver to sleep, or are you trying to keep the driver awake so that they can see the pedestrian? So here's just some images that Ron sent me. These are the before and afters, right? This is before, and that's the after. So these are actual applications here in Maine. There's another before, roundabout, after. So there's a big difference when you look at them side by side. Okay, this is another one of my pet peeves. So get on my little Shaina soapbox here. I've got, 3 Eagle Scouts and one more on the way. So we go camping a lot and hiking, and I'm a big dark sky proponent. And you might think like, okay, Shaina, really? You talk about lighting, but you like dark sky. You think it's like an oxymoron, right? But if we design lighting right, we can have dark sky. I don't know has anyone been to Phoenix, Arizona? Have you ever like when you fly into Phoenix and you look down, the entire city's dark. It is amazing. They have the strictest full cutoff requirements. No light is allowed to shine above 90 degrees. So what we're talking about here, when we look at lighting, we think of these 3 characteristics. It's called the bug rating, backlight, uplight, glare. And we're trying to just make sure that if we're going to select a fixture, we want it to put the light out exactly where it needs to go. So this is an example. This is just your standard acorn. Everything there in red, that's all the light that's going up into the sky that's not doing anything but lighting the sky. And you're like, oh, well, it makes it pretty. No, it's called glare. So when I look out, my hotel window, I see these. And anything that goes above 90 degrees is just wasted. Okay, so I want you to think about which fixture you're selecting and why, because it is important. And there's a lot of products out there that, all these new styles out there that are full cutoff. So what we're talking about is having that top cap on, or and even having more of the flat glass. As soon as I put a refractor, even though all the light is in that top hat and it's coming down, as soon as I put a piece of glass there, refractor, a lot of that light's going to go right back up. So just be very aware. It's also more efficient because all the lumens that are coming out are actually going down, whereas here, half of them are going up. So I needed to put twice as many poles. So not only is it inefficient, it's more costly. You have to put twice as many lights up, okay? Glare, background luminance. So I try to take photos from areas around Maine, and I don't know where this is, but it looks fun. But there's the crosswalk, and it's got great contrast. It's black and white, you can see it, but does it pop? Does it stand out like those other ones where we saw that crosswalk was bright and the roadway was a little darker? That's what we're looking at. We're looking for that contrast. Skyglow and inefficiency. That's a lot of lights going down that sidewalk. I don't even, the sidewalk isn't even lit. Do you see that? They were trying so hard to get that sidewalk. Let's just put another light in. Let's put another light in. No, it's not gonna ever get there. So this is the concern. So I'm a big proponent of full cutoff fixtures whenever possible. Any questions about that? No? All right, warrants. I'm not going to read all this. I just want you to know that we have automatic and calculated warrants. Automatic warrants are saying that we believe that this application is a wise choice to install lighting. Mid-block crosswalks, crosswalks at a signalized intersection. And then if it's unsignalized, it's where at least one approach leg is continuously lit. If you've got lighting, continuously lighting along a roadway, and then you get to the intersection, it's not signalized, and then it's dark, it kind of, we're talking about contrast. We want the intersection, the crosswalks, to be brighter than the roadway. God bless you. History of at least one pedestrian crash, proximity to schools, churches, bars. It's a funny story. Okay, so older prescriptive warrants. This is where we kind of came up with this idea. So these are warrants. Has anyone seen these ever for like a warrant? Just the, well, this is the New Jersey one. Obviously, you haven't seen that. But we actually, the Transportation Association of Canada is a guideline we use a lot for roadway lighting warrants. I think they have traffic signal warrants as well to figure out whether or not you need it. And we looked at these and said, okay, great. These were written, whatever years ago. But none of them were written with the thought of pedestrians. They were all written for vehicular safety. So we added these concepts of what makes a warrant. What do you have to think about when you're like selecting something for a pedestrian? So inside the MaineDOT guideline is this new warrant calculation. It looks scary, it's not too bad, because all the terminology in there for roadway, we actually put into here. We define everything, every vocabulary word that we use in the warrant, we defined to make it really easy to understand, well, what do we mean by that? And there's 4 categories. I'm just going to fly through them because you can read more about them. But the first step is we like to take like a photograph and put it here and identify if the lighting is automatically warranted. If it's not, then you use this calculation. Remember, this is just to help you prioritize. Where are you going to put it first? A whole bunch of geometry factors about the road, if it's curved, if it's sloped, if there's channelization. And then we talk about operational factors. This is your average daily traffic. And what it is that once you get these factors, you figure them out. If I've got average daily traffic on a major road or minor road fits this criteria, this is the rating factor. We multiply it, and then you get a number. You add all the numbers up at the end, and if you're over 100, we're like, okay, that's probably a good application for lighting. If you're over 150, we're going to tell you we want full intersection lighting. We want you to light the whole thing, not just the crosswalks. We want to light everything. Okay, so this helps you prioritize. So we have the operational factors, the environmental factors. So these are the ones that really change. So we've got the presence of disability glare, frequency of inclement weather. I added that one here because I was driving up and I realized, guess what? It snows a lot up here. And what color is snow? White. What color are your crosswalks? Black and white. So when there's snow on the ground, you can't see the black. The contrast is gone. But if you light it, you have that glow of light right there. Guess what? You start to think, oh, there's a crosswalk. Plus, you've got these beautiful, I have to give MaineDOT a shout out. Everywhere you see those pedestrian signs at every single mid-block crosswalk, you see one on either side, those bright yellow signs. We're just trying to draw attention via light, via signage, flashing beacons. That's what this is about. And then we have the last one, our safety factors. So we also added like history of speeding, crashes, history of crime against pedestrians, or perceived crime. Someone doesn't feel safe, light it. Okay, so that's the warrant. Now, quick, what are the new pedestrian lighting classification types that are in the guideline? I'm like, okay, I'm doing good halfway through. So think about contrast again, right? You guys don't have a lot of roadways that are continuously lit, but if it was continuously lit for one approach or two approaches, you just want the intersection to be brighter because of contrast. Very good, contrast, okay? So now, if these aren't lit, I'm just gonna light the intersection, and this intersection is the same light level as kind of these. It's not as bright because I don't need as much contrast. And then over here, so this is the old classification. This is what how many people have ever looked at an IES design guide? Raise your hand. Yes. 1, 2, 3. Well, I know you guys, but all right, we've got. This is what they had before. And we went out there and we looked at a whole bunch of applications and said, this is that Cobra head on a utility pole. No one here works for the utility company, do they? Oh gosh, really? Okay, don't get me fired. I just want these Cobra heads to be, if you're gonna put one on either side. That's my goal. So we did we looked at, this is actually a real project that I had down in Jersey. And they came to me and said, Shaina, okay, we want you to design it. You've got like 100 intersections. We want you to put in lighting and electrical. And you only get 4 poles per location. And I said, okay, but they're all different sizes. Some of them have multi-lanes. This has 7 lanes across. It doesn't look that big from Google Maps, but guess what? It's a big intersection. And I'm like, I don't think I can design it with 4 lights. They said, well, that's all you get. You get 4 lights because that's what the, some IES thing had a picture, or FHWA guideline had a picture and had an intersection at 4 poles. And they're like, okay, that's what we're gonna do for everything. So I actually took it into AGI. This is a lighting software that I use. I'm an AGI certified instructor. I love it. It's great. So this is actually the image that was in FHWA guideline. And that's what it looked like. Because I was trying to tell them, like, please let me put more lights in. I'm not trying to sell you more lights just because, I'm selling lights. I just want it to be safer. And here's another view. How many of you can see the pedestrian in the image? All right, so there's one right there. How many of you see the second pedestrian in the image? No? You've all just killed that person. Not to be morbid or anything, but okay, so there is another person over here in this crosswalk. So this is the issue. This is why we got rid of that. Someone said to us at our last training, isn't just any light a good light? No. This gives you a false sense of security that that entire crosswalk is safe. And is it? No, it's not. So if you take anything away from today, just know that we just want you to design it right, okay? Just think about lighting a little bit differently. So this was the intersection with lighted, we actually had, instead of 4 lights, we had 8 lights. Looks beautiful, everyone's safe. You see all the pedestrians. Bob's your uncle. All right. New pedestrian lighting classifications. So these, we got rid of you saw this one before, you saw this one. We actually did this, because what if you just have one roadway that's lit? Now remember, this is uniform lighting up into the roadway. This is not just a Cobra head on every other, utility light. This is when you have uniform lighting. And you guys don't have a lot of that up here, and that's okay. But we got rid of that beacon light and said, if you're gonna light a crosswalk, I want you to do it well. Make sense? Good. All right, now design criteria. Remember those like 50,000 guidelines? I've read every single one of them. My head is spinning. They all say something different. And then we looked at them and tried to realize, okay, what is the point? The point is to create contrast, okay? So we looked at all of them, read through them, and we didn't just summarize them. I didn't just read these and go, okay, well, this one says this, and summarize it and put it. We evaluated them. We looked at them and said, why? Why? I'm like that 2-year-old that's like, well, why does this one say it? And why does this one say this? And why does this one say that? Why does this one say horizontal and vertical and luminance and illuminance? Why are they all different? because a lot of them were written by people who don't do lighting. They meant well. But lighting designers and people that, that we work on these applications, we weren't consulted when they came up with these. So I'm actually starting to work with more and more universities because they'll have students that are doing a paper. And guess what? Does that student have any practical lighting design experience? No. But they're going to study something, they're going to write a paper, and then some DOT is going to say, oh, well, it came out of this university, so it must be right. And I'm like, it's wrong. That student doesn't know what they're doing. So I'm trying to work with these universities more and more to kind of help them and guide them. All right, so has anyone seen the AASHTO Roadway Lighting Design Guideline? Couple people. So this one out of all of them, I believe, is the most accurately represents lighting foot candle levels in relation to lighting classifications. So for example, you've got arterial, collector, local, major, minor, all these different FHWA classifications. You guys know those? Yeah, you've all heard of those. So you've heard of that. You've heard of that. You haven't heard of Illuminance or Luminance, but that's okay. So they have all these different lighting criteria, foot candles for, so right here we've got principal arterials, minor arterials, collectors, local, alleys, sidewalks, and then there's all this other luminance. This is all going away, by the way. I'm working with AASHTO to get rid of that part, but that's a whole nother story. Area classifications, commercial, intermediate, residential. So this is interesting because what you guys consider commercial, I consider, like down where I live, more residential. It's just based upon population density. So being from Jersey, we have, my little hometown is a mile long and it has 10,000 people. So our population density is a little bit different. So we wanted to take the Maine guidelines and really relate them to you, to your needs. Because a lighting design guideline that was written for New York City, it may not always be appropriate for Maine, okay? And that's what we wanted to do. We wanted to customize this for you. So we just kind of standardized all pavement luminance R2, and we combined that and said, okay, that is going to be our design criteria. And then this was another study. This is the latest study that's out there. And they're talking about, so we've talked about horizontal illuminance, then there's this vertical illuminance, right? With this concept of creating a positive contrast on a person. Well, how much light do I need to do that? A lot of studies out there, but remember, the point is, I just want to be able to see that person in the crosswalk who's 200 feet in front of me. I don't need to floodlight them. I just need to see them. So how much light is just good just to see them? And that's what this study did, because there's a pedestrian lighting primer that came out that was written, FHWA pedestrian lighting primer. I'm sure none of you have read it except for me. But it talked about 2 and 3 foot candle vertical in the crosswalk. That is a huge amount of light. That's a huge amount of light for Jersey, let alone Maine, okay? And so there's this concept of like, is it safer the more light you put in? No, it does. It kind of tapers off, right? So we want you to put in enough light that lights the pedestrian, but we don't need you to go crazy. We don't want to, have light shining up into the sky. We want it all to be useful. And so we standardize on these 2 things. AASHTO for the horizontal, 1 foot candle for the vertical. Done. Sound good? Simplified it, so you don't have to read all 20 guidelines. Now, how do you locate the pedestrian lighting grids? This is going to be our exercise this afternoon. So, I do have fun little giveaways for folks who come to my training this afternoon. I'm trying to entice you to see that. I'm trying to entice you to sign up. Aren't they cute? Come on, it's a light bulb. Come on. All right, let's talk about just creating these calculation grids, horizontal, vertical. Has anyone ever seen this before? These are those conflict points between a vehicular and a pedestrian. Okay, I see a lot of heads nodding, good. These are all the traffic engineers going, yes, I've seen this, good. All right, so the red is what all these other guidelines were designed for. It's designed for cars, not for the yellow dots. And that's what we're doing with this guideline, is trying to connect the dots. See how I did that? Yeah, puns. All right, now the horizontal grid. If I look at that intersection, these are things I want you to just understand that there is no one right answer. We just want you to think about how you're designing. Okay, there's a little bit of subjectivity that comes into a play here, and that is okay. So this was an intersection. I think it's here. I think it's in Augusta. I think we talked about this one. Veterans Memorial. Is that in Augusta? Lewiston? Okay. I don't know. I just try to pick all these. I go on Google Earth and I'm like, that intersection looks good. And then it's on my presentation. So this horizontal calculation grid, you typically, when you design an intersection, we say it's like bounded by the stop bars. So there's the stop bar up here, but I also have this island. Do you include the island or do you not? I like to, when I design a crosswalk, no one ever walks exactly in that, 5 foot, 6 foot crosswalk. Sometimes they walk, a little bit out. So I like to extend my calculation grids just a little bit wider. Sometimes people add it onto the sidewalk. If you can extend your grid onto the sidewalk. So there's the stop bars over here, stop bar, and then there's no stop bar on this side. So I just kind of do a horizontal line, but I don't always, it depends. Sometimes I'll angle it. And then over here, this is the crosswalk, but I added an additional lighting area because people were going to be like walking from here or something like that. I was like, you know what, they're gonna try to cut. They're not gonna walk all the way over to here. They're gonna go over to here and cut right through there. So it's just, I want you to think about it. Make sense? All right, now let's talk about vertical illuminance, okay? So for this, we're going to go for a little drive. So here's that infamous Jersey intersection that I had talked about before. And when I design lighting grids, and I don't want to stand in front of you, but if I go back there, it's going to so let's look at these grids. I've got different cars coming from different directions. So when I approach that crosswalk, what I'm thinking about when I design the lighting is how do I put a positive contrast on that person, okay? So as that car approaches, I've got pedestrians that could be here, left turn, straight, right turn. This is my right turn pedestrian, that's my straight through pedestrian, that's my left turn pedestrian. Then I've got the green cars coming from the south. I've got straight through pedestrians to the right, to the left. Blue car, straight through, to the right, to the left. Purple, straight through, to the right, to the left. I've got all these different conflict points that I have to design towards. And you're like, how hard could lighting be? It's complicated because we have to work around underground and above ground utilities. Is every intersection perfect? No, you've got things there, you've got bus stops, you've got all these other constraints to the geometry and existing conditions. So what the whole purpose of the guideline is we want to give you the tools to get close, but we understand that sometimes you're just not going to be able to get there because there are some constraints. There's a big sewer line running underneath exactly where you want to put the pole. Okay, so we just want you to get close. So that's every grid that I would design to make sure that my lighting is compliant. And these are the vertical grids. So for this blue car going over here, I've got a grid there, a grid, these are my through grids. This is my right turn grid, this is my left turn grid. And when I do this in AGI, when I do these photometric calculations, I take the grid, and it's not just like, when we do foot candles on the ground, has anyone ever seen a light meter? A couple of us, right? You take the light meter, you stick it on the ground, and it's shining, straight up, and it says you have 5 foot candles or whatever on the ground. When we're doing vertical luminance in a crosswalk, so if this is my crosswalk, I take this vertical grid, I'm going to put it right here, and I'm going to aim it in the direction of the oncoming traffic. So it's not just straight out, it's where's that car coming from? That's what I care about. How does that car see that crosswalk? And that's what this is. So there's the grid, and it's actually aimed in that direction. But be very careful. So here's the orange car. Very simple. One's coming from the right, one's coming from the left, right? Because guess what? This one has an island. This one doesn't. You think that car is going to make a beautiful, nice sweep? No, it's going to cut across. So I actually extended the grid for that one a little bit longer just to make sure that the lighting was compliant. And after doing hundreds of these, I kind of know what will work and what won't work. And you will too. All right, so do I expect you to do these, 13,000 calculations for one intersection? The goal is to understand the concept, okay? And if once you get a couple that work, usually all the rest kind of fall into place. And this is just showing you in the software that I use that there's actually this variable meter aiming point. That's how I aim that grid in the direction of the oncoming traffic. I show you this because not all lighting software has this. Okay, so I've got like 2 softwares on my desk, and there's one that has this option and the other one doesn't. So I use this one for vertical. How flexible are lighting design recommendations? So this is the key takeaway. After all the time I've been doing lighting and submitting, my pet peeve is when I submit a set of plans and I explain to them my whole thought process of why the foot candle here and the foot candle there and the illuminance and the uniformity, and they'll reject me because it's like 0.9 instead of 1.0. I'm like, are you kidding me? And they don't look at it holistically. So every intersection, every crosswalk is completely different. Please understand that. 4 poles doesn't solve it. Okay? I just want you to appreciate that, like, this is an intersection, and these are all the different grids. So I've got, as I'm coming from the north, okay, so this is a south, SR, south right turn grid, south straight. This is for the north left turn grid, north straight. This is for the right turn grid, right through, or straight, whatever. Moving westerly right turn, moving easterly right turn. So you can just kind of label all your different grids. But the whole point is these are where I'm concerned about people walking, so I just have to make sure that the lighting lights those people properly. Make sense? All right. Now, this is the real application. This is that intersection. So I went and designed it. Said, okay, I'm going to put poles up. I don't care about underground utilities. I don't care about above ground utilities. I'm going to put the poles where I think they need to go to best light the pedestrians, okay? Working with the existing geometry. Do you think I could get the exact same foot candle level vertically on every single grid? No. It's impossible, okay? Because there's always, different constraints. So there are guidelines out there that'll say 2 to 3 foot candle vertically in a crosswalk. That's a lot of light, folks. We've kind of standardized on that 1 foot candle because after that, what the studies show is it doesn't mean a hill of bean difference. If you light it from 1 to 10, it's just more light, but doesn't allow someone to see someone any more than it did before, okay? So look at this, the horizontal grid, nice 2.0 foot candle, that meant the AASHTO compliance, great. But now let's look at the vertical grid, 1, 1.3, 1.02, 1.6, 2.47, 1.97, 1.28. If I had submitted this and someone said design it to that pedestrian, FHWA pedestrian lighting primer that says 3 foot candles, they would have rejected this. What the goal is when we're designing lighting is to, my minimum average right here, the lowest one, 1.02, 1.06. If the other's a little bit more, that's okay. But I don't want the other ones to be below it, okay? So it's a art, not a science. So if people are submitting plans to you and you're going to review them, these are the things that we want you to think about. So there is flexibility in this design. There's flexibility in how you lay it out. There's flexibility in the actual foot candle levels. But just remember, the most important word is Very good. All right, fantastic. So is this a good design? Would you approve it? Yeah, it's a good design. I mean, I did it, so of course it's a good design. But the bigger question is this a safe design? And that's really what we're trying to get at, okay? 1.3, 1.4, 1.7, we're just trying to make the roads safer, okay? Would you approve this design? Yes. All right, so why is flexibility needed, right? That was the whole point of this guideline. Well, not one of the whole point, but just an important characteristic of it. Different luminaire style, optics, wattage, lumens. So Steve and I drove around, was it last year or 2 years ago? I took some more pictures on the way up. I was driving through Bath. They had different fixtures. So we went to all these cute little villages and we're driving around and we took a photo of the light and then we went to the next village and we took a photo of the light and then went to the next one and looked at a photo of the light. We went to 13 different locations and no two of you have the exact same light. Different heights, different styles, different fixtures. Some are full cutoffs, some are not. Some have arms, some don't. There were so many different options, okay? So you have to design, we're looking like take the style that you've selected and let's apply it as best we can. Different luminaire heights. We also have above and below grade obstruction. So I'm working on like some roundabouts with MassDOT right now. And roundabouts it's popular. You guys even have some in Portland. There's like some new roundabouts that I saw. They're beautiful, right? And it's this, but obviously you've got above and below ground obstruction, so I couldn't always put a pole exactly where I wanted to, because there was, on one of my projects, they're like, well, there's a monument there. I'm like, can I move the monument? They're like, no, not moving the monument. I'm like, are you sure? I'd really like to stick a pole there. No two intersections, crosswalks have the same geometry. These are theoretical lighting calculations, by the way. It's based with an ideal fixture from the manufacturer. And we use something called a light loss factor. Has anyone heard that term? It's like when I design it, the light that you get on day one is not what I designed to like a 0.75 or 0.85 light loss factor so that I designed to what the light will look like in 3 years. On day one, it's going to be a lot brighter. Dim it down. But in 3 or 4 years, does anyone clean their lights every once a month? You all go out and clean every street light? Have you ever cleaned a street light? Come. They're all giving away. Just nod your head. Yes, we clean them all the time. The rain does it for us. Does the rain do it for your car too? Yeah. Except for you have a fifth season here, it's mud season or something? Okay. So they're theoretical. We try to get you what the light's gonna look like over a period of time. And then it is subjective, the horizontal and the vertical grids. How far? Do you use a crosswalk? Do you use the sidewalk? Do you not? There are a lot of factors. We just want you to think through it. Varying existing conditions for the approach roadway. Some are lit, some aren't. This is another one that I'm talking to with a couple universities about is the percentage of calculation points in compliance. How many of you have done, raise your hand high now for like to have done a photometric calculation? 1, 2. That's it? Oh, job security for us, yeah. So when I do those calculations for an intersection, I'm always gonna have outliers. So directly right underneath the pole, you're gonna have this bright like 5-foot candle. But then if you go like 2 feet over, it's 1, and then it's 0.9, and then 0.8, and then 0.7. But right underneath that pole, you've got this 5. So if I took that 1 point out, guess what? It's a beautiful uniformity. So we have these things called outliers, and something that we're talking about going, well, if I have 99% of the points in compliance, is that okay? Because we don't want you to delete points. It's kind of, we want you to keep everything there, but so it's just another concept. And then remember, this is a guideline, not a standard. A standard is a rule, you have to do it. You have to put a stop sign in at a whatever. Those are rules. This is a guideline to help you design safe. All right, 5 minutes to spare.
Tommy, you're the first one to use this design guide. Give us some feedback on.
Only if it's good, though.
No, I think it's pretty good. And I think it addresses most of the conflicting points of other lighting standards. So it's definitely easier to understand than flipping through 100 documents.
And I want feedback. So if anyone else decides to read it, you know, my contact information's up there. But we do want feedback to what's good, what's not good. I'm a perfectionist, so I want to make sure if there's anything that's not clear, if you see it, just message me and let's, you know, make it as best we can. And I will say, this is the first guideline of its kind in the country. I'm damn proud of that. And now there are actually new studies coming about because of this, where they're looking at warrants and changing them for pedestrian. There's a new one that Virginia Tech is working on that's new warrant guidelines for roadway. I wonder where they got that idea. But it's good. We're making people think and changing the norm. So, all right, that's it. That's it. That's all. Oh, another question. Yes.
Yes. You guys talked about how to light pedestrian, and we've played around with a little bit of lighting ourselves, but we did it when it was pedestrian activated. And I'll talk about that later. But one of the things that we
Next.
found was when you light pedestrian, you talked about this earlier, is if you light them from the wrong side of them, it's even more difficult to actually see them. In other words, if the light's coming from this side, and you're
Yeah.
driving from this side. How do you design for that on a full signal where you got all these different approaches?
You try your
only
best. You try,
we only
yeah.
looked at like a pedestrian crosswalk mid-block, which is easy in comparison to what you're looking at. How do you do that design that you're not shining the light on the wrong side of the person?
So if I looked at this one, and I've got a car that's coming down here, I want the light in front of the pedestrian that's crossing here. And then as I get over here, this car is going straight, so I'm trying to put the light in front of the pedestrian over here. But over here, I had a traffic signal, so I couldn't quite put the light right there. I put it to the side. Okay? So I'm trying my best to get as close as I can, but this, hopefully this light will help provide that positive contrast. So you're just trying your best.
And are you using different
Optics?
type of luminaires,
Yes.
like the type 4
Yeah.
luminaire?
I think you guys are going to see that. Is they going to see that today? Is there someone here from a manufacturer?
Yeah, I think the next.
Yeah. So there are thousands of optical distributions of lighting. And in a forward throw, so there's like a type 5, which is a round. There's a forward throw, a type 3, a type 2, type 1, okay? And there's a new crosswalk optic. They don't have it in every product yet, but it is a light that is designed, so if this is the crosswalk, right, I'm going from here to there, it's designed, so I'm gonna put it ahead of the pedestrian, you guys are the roadway lanes, and it shines light this way, but also kind of up a little bit. It's a really neat optical distribution. And then you put it the other side. So I will say, like, one of the roundabouts I did see, one of the newer ones that was installed, it had both of the poles on the same side of the crosswalk. Well, the one pole was good for the person crossing in the one direction, but as the other car was approaching from the other direction, it was backlighting them. Does that make sense?
Yes.
So you want them staggered. You don't want them both on the same side. Yes, question in the back.
Question for you. What are your thoughts on, excuse me, allergies are killing me.
That's okay. That's okay.
What are your thoughts on the difference between static lighting schemes and progressive lighting schemes? And what I mean like that is
Variable in the light level?
not
Or,
variable in the light level, but I've seen a system where, and I believe there's a representative here that has this type of system where it actually leads the pedestrian across.
oh, I love that. Look, this is all about contrast. Okay? Lighting. The lighting is important for the driver who's 200 feet away. But then the flashing beacons or the lighting in the ground, there's even some countries that are doing like glow in the dark striping, you know, anything that draws attention, that creates a visual contrast to see that pedestrian is what we're talking about. So I'm for everything. I want, you know, fireworks going off every time someone walks across. But you know, it's personal to me. This is a personal mission of mine, is to get this right. What, do you have another
No,
question?
no. Your point of angling the lights, we found it.
Well, no.
angled it
It's not.
slightly.
You don't. Okay, don't angle a light, but at the optics kind of are designed to push light this way forward and this way.
Okay.
It will
It's a
automatic.
lens.
It's a lens. The lens, the optics of the lens, like are designed to go this way. So not just like, you know, forward throw, but they have light that goes this way, but not that way for the crosswalk. It's kind of hard to explain. I had an image in here, but I think you're going to learn about
So
it.
we found that if you had the correct lenses as well, it
Lens.
also stops the light from going in the light
Yes.
of the driver's eye.
Yes. So that, if I could get rid of the acorn light, I know I'm never going to get rid of it, but I'm going to do it one light bulb at a time. It's glary, okay? So remember, if you're going to go through all of this trouble of putting rapid flashing beacons and lights in the road, as soon as you put up that acorn, that's a bright light that your eye's going to see first. Think of a photograph. If you take a photograph of a light at night, does it turn out? Well, now with these new phones, they can do anything. But before that, right? It was this big glare bomb. The contrast was too much. It distracts you. So just think about it. Let's try to get the light down and less glare.